wanted to talk today about the notion of rethinking connectivity and what I mean by that, what I don't mean by that, and why I think we might be at an interesting inflection point, kind of in the technological history, so to speak. I've been doing this now for about 33 years. I've spent most of my time and energy in distributed systems and the way they communicate and collaborate and coordinate together. And so why would we even want to think about rethinking connectivity? There's been a lot of folks who still believe that what we have today is fine. And I'll be quite frank, you know, in the early 90s when I started work on these types of things, certain verticals definitely took advantage of this type of thinking. And I naively, as a 20-something-year-old at the time, thought, oh, everyone is going to think this way very shortly. Obviously, I was wrong, or more succinctly, wasn't necessarily wrong per se, but was way off on my timing. And so for me, what I've been watching over the last probably 4 to 6 years at an accelerating pace is that building these technological systems, these global distributed systems, is just too hard. It's too slow. We were with a customer the other day who said that they had budgeted 9 months for an initial rollout and a POC of a global type system, and that they would probably deploy around the 14 to 16 month time frame. And I believe that most of us in this room believe that innovation is kind of a function of velocity. You need to move quickly, and in my opinion, 14 to 16 months is not necessarily quick. I believe that every impactful technology either is already today or very much will be global, multi-cloud, edge-aware distributed system. And I've kind of gone on record, and again, I probably get more things wrong than right, but I went on record about 6 years ago saying that my belief would be that edge would dwarf cloud, and that cloud is going to quickly become the new mainframe. It'll still exist, it'll be there, but it's not going to be something that we're interacting with. And I get challenged a lot on that, and a lot of people are correct. They're actually correct, and I'm necessarily wrong. But I will point out that you probably are interfacing with what people call the near edge, so to speak, more than you think, even on a daily basis. And you're starting to see a proliferation of things like, you know, Fastly and Cloudflare and Lambda and edge functions. And of course, CDNs have been caching the majority of the internet traffic for quite some time, meaning that you're actually not talking to an origin provider there whatsoever. As I mentioned, I think we're at a major inflection point. And it's interesting because technology, as most of you probably know, moves both very, very fast and very, very slow in the moment. But I can promise you, at least in my opinion, we're moving at a breakneck pace. What our world's going to look like 10 years from now is going to probably not be anything that we could even imagine. And again, having been around for a while, you know, I remember shouting at the rooftops in late 93, 94 about this new thing called the internet.
Maybe I've stepped away from...
And I was so adamant about how this was going to change everything. And I was completely wrong at the magnitude of what actually got changed. And if you think about it, every single massive change that we've had, again, in my opinion, has been predated by a physical connectivity layer, right? DARPA, the internet, IP, cellular, global cellular, where it actually would work when I landed here in Copenhagen. I remember years back it would not, and then if we were on different providers, it would not. And we're starting to take this for granted, and with the world pandemic that we've all lived through, I think it kind of forced this notion of the power of connections and connectivity. I personally really don't believe that the future we're heading towards in a rate that's very, very fast is going to be dominated by cloud, HTTP, and DNS. I have a saying that, you know, always blame DNS, and I say it a little bit tongue-in-cheek, but sometimes not. So I believe innovation is being driven by technology. I believe every technology is a distributed system. I started in vertical scaling in my university days, and by happenstance quickly got thrown into a scenario where my first job, which was at Johns Hopkins, the Applied Physics Lab, I got selected by the second best physicist at the lab, not the first. So I didn't have a lot of supercomputer time. And they kept saying, well, can't you make those 12 Spark pizza boxes do the same as, you know, a Cray or a connection box? And of course I said, no, you can't do that. It's vertical scaling. And I was very, very fortunate that I got selected by the second best. And so even as early as 89, 90, I started on this journey. But I believe every technology we're interfacing with now is a distributed system. What I also, though, think is happening very, very quickly is that everything is global. You know, Europe, a lot of European financial institutions are forced to be multi-cloud today. It's multi-geo, and again, it has to be edge-aware. And I think these systems are powered by connectivity. And so I think innovation, as we define it, is really powered by connectivity. And again, being able to kind of see and look back on my own history when server rooms used to be very, very small and very, very cold, and I wasn't very, very big, and so I was the person that would crawl underneath and run the cables underneath of the floating floor. And you would see these blinking lights that were
Have this term in Danish, playing games.
either a spinning disk or the CPU. And of course, if anyone's been in a modern data center, right, you don't see any of that. You see wires, connections. That's all you see. And I believe you could even look further back in terms of the global cellular network, internet, and even to our own biology about how we are defined by the connections, you know, in our brain, not necessarily the DNA and the actual individual cells. So what's connectivity? At least from the purpose of this talk, what is connectivity? And what are we trying to rethink? And I want to be really clear here because I think certain parts are not going to be changing. And believe it or not, that's kind of the what. And so I call it the how versus the what. And what I mean by that is the what is, what's the application actually doing? And I truly believe that that will not fundamentally change. I try to make things very, very simple so that I can understand them. We live in a very, very complex world. And so I try to dumb things down almost for myself so that I can actually communicate well. And so for me, when someone says, what do you mean? You know, what are the what? You know, what's an app actually doing? And in my opinion, it's really doing only two things. It's either asking a question or making a statement. And of course, the corollary on the other side is answering the question and, of course, processing the statement. And actually, the modern world that we're starting to see is that the second corollary that I talked about there is gaining an increasing popularity simply to drive the efficacy of the first corollary. So what I mean by that is if you look at distributed systems today, the majority of them are request-reply, asking a question, getting an answer. Where you're starting to see telemetry and event streams and data streams and batch processing and real-time processing and inference and all these other really, really cool technologies that are coming along, I really believe at the end of the day, it's simply to be able to formulate a better answer to a question. And so, and of course, these basics kind of translate into more techno world speak, so microservices and event and data streaming. And again, I think these will evolve but won't really change. The core of what the application is doing will always be similarly the same. But I do believe that we need to rethink the how. And again, it's because I honestly believe we're at that inflection point where things are moving at such a rate that what used to work and was good enough, as we all know, computers are very, very fast. Back in the 90s, you know, one of the first problems we were trying to tackle was this notion of stock distribution in terms of the information, like what's the stock price of Apple or Google or Meta or whatever like that. And humans, as we all know, even the best humans, right, are about 160 milliseconds when they can tell something is slow. 200 milliseconds was the gold standard at Google, at least while I was there. Once a request hit the front door, it had to be out in less than 200 milliseconds. It was based around the psychology of the human brain, but let's say 160 milliseconds. But in the late 80s and early 90s, fin services, at least in the United States, but I think globally it's pervasive now, the notion of programmatic trading was coming in. And back in the day, what was happening is that the computers would literally dial someone up, call them, say, hey, the price of Google is this, hang up, dial the next person. And computers are very fast. They're even getting faster. We're going into a mini renaissance again of hardware acceleration, which is awesome to see for me. But obviously at programmatic trading, the last person in line is going to be hugely disadvantaged, where 160 milliseconds is a huge amount of time. And so this notion of, in the early 90s, of even saying, hey, can we change telephone calls into a radio broadcast where everyone gets it at the same time? It sounds trivially simple. And it was in terms of writing it down on paper. Doing it was a little bit harder. But if you look at today's systems, they're still doing individual telephone calls nonstop all day long. And so when I talk about rethinking the how, what I want to talk about is what I term connectivity pillars. And these have been built up over, unfortunately, 30 plus years of bumping elbows and scraping knees, meaning it's more about the scars on my back than anything to do with IQ or intelligence. It's just, I really thought that would have worked well, and again, it did not. And so for me, there's four major ones, and we're going to walk through those and describe what those necessarily are. And what we're going to do is we're going to wrap all of this into an example kind of at the end to kind of ground some of these in a real world example. But we got fundamentals, we got topologies, security, and persistence. And so when we talk about fundamentals, these are easy to kind of overlook and almost kind of say, it doesn't matter. But I promise you, at least from my experience, all of these pillars are required, and they all depend on each other, and they all actually require each other. And so, for example, the first one, location independent. What I mean by that is that if I want to, reach, let's say, a microservice, I should not have to care at all whatsoever where it is. And an interesting corollary or an interesting example to think about is kind of, again, for the folks that have kind of been around, similar to myself. We could conduct business with telephone numbers and making calls on wall phones and desk phones. I'll be frank, I don't even know my own adult children's phone numbers anymore, right? I just click on their name. I don't care what cell provider they're at. I don't care where they are. I have no clue where they are, and I don't care. And so this notion of location independence, or actually what I call truly nomadic applications, meaning an application can run anywhere, can connect to any point within, whether it's the cloud, the edge, on-premise, it doesn't matter. End-to-end communications. The majority of systems today are built, the ones that we consume are built on HTTP, which is inherently one-to-one by default, right? Companies do, for lack of a better word, kind of unnatural acts, so to speak, to get around that. But I believe the world we really want to go to is end-to-end. And what I mean by that is patterns where I can ask an unknown set of responders a question, and I can get back either the fastest answer or the best answer, even if it's totally different parties, right? I can be asking Google and Apple the same question. I just want the best answer type stuff. The ability to have multiple parties actually interoperating together. One of the interesting things that one of my mentors in the 90s said is, when you generate a piece of data, an event, we called them messages back in the day. Never assume today what the message will be used for tomorrow. And I think that's really powerful. And it took a while for it to sink into my young brain at the time, that we don't know tomorrow what's going to happen. And you can see this in production systems by, it works on the developer's workstation. Now we have to add in load balancers and security and logging, and then there's governance, and then there's audit, and then we're trying to do anomaly detection. Now we want to actually hook it up to a different service. Now we want to be in a different cloud. We want to be in a different region. All of those things should just be baked in my opinion. Utility versus silo. This is an important one that's more a change in the consumer bias. And so what I mean by that is that right now, any technology, for the most part, is everyone has their own. We call it the siloed effect, right? I have my own database. I have my own key value store. I have my own messaging system, right? And even within the same company or organization, other people have their own. And eventually you're always going to get to this point where you're trying to glue them together, right? And so one of the first things that we thought really hard about 4 years ago is how do we present a technology where we can slowly change the consumer bias that this should be a utility, like electricity, like the internet, like the global cellular network. Whoops. Is it possible to have the monitor turned back on? It timed itself out. If not, I can just keep turning around. That's totally fine. But the utility notion is truly like kind of like this electricity, right? Where everyone has access. And again, with the global cellular network, kind of the best, latest example of it just kind of works. Or maybe Zoom, if people use Zoom, right? It just kind of works. And the last time I was on a one-to-one Zoom call, I can't really remember. It's always kind of this M-to-N. But it's just like a dial tone almost, using very old language there, in terms of how you consume the ability to connect and communicate. Self-healing's an interesting one. It can mean a lot of different things to a lot of different people, but we've been practicing this now for almost a decade, where the system will put itself back together. You don't need someone staring at a knock and having pager duty ring them and wake them up in the middle of the night. And again, these are all being built upon as we go forward. And then physical substrate agnostic, but I think we're kind of already there, right? This is kind of one that I've had in my mind for quite some time, but I think we're kind of there, right? You don't know if we're going over Wi-Fi, cell, satellite, dark fiber, doesn't matter. Topologies is the next one. And again, hopefully when we get to the example, it'll make some of these more concrete, because I know they're kind of abstract right now. But node versus server is kind of like the pet versus cattle. It also intertwines with one of the fundamentals around location independence. I don't think there should be one thing that's running in AWS East, if you're from the States, on AWS, and it's at this IP address, right? These things should literally be able to be Lego bricked together in any topology, any type of configuration. Some of my favorites are full mesh one hop, directed acyclic graph, superclusters, hub and spoke, those types of patterns. It should be pervasive. And what I mean by that is, and again, trying to use a metaphor and example of where I think there's the limitations. If you and I sit in a room and we're texting each other, WhatsApp or iMessage, it doesn't matter. And we're not necessarily, well, even if we're on Wi-Fi, but let's say we're on cellular, right? When I text you, it's actually going to a cell tower. It might be the same cell tower, right? A lot of times they're communal, so to speak. But it usually will go to a central office. 5G's trying to make that a little bit better. Might bounce between central offices if you and I are on different plans. Come back to a different cell tower and then kind of hit your phone, right? This notion of tromboning, again, for humans at 160 milliseconds or so for the best of us, might not be that big of a deal. But when you start to talk about systems, right, that tromboning effect is a big deal. And you see it with, oh, we need a global presence, right? We need to be multi-cloud aware. We need to be edge aware, whatever that is. It's essentially trying to pare down this tromboning effect, right? And so what I mean by pervasive is this node, again, not a server, not something that you have to care and feed, but this node where if it's there, great. If it's not there, nobody cares type stuff. Should be able to run on 256 core, terabyte of memory type of very, very big hardware. But it also should be able to run on a Raspberry Pi or even smaller, meaning that the pervasiveness allows through the ability to run on very small devices to run in top-of-rack switches, in home Wi-Fis or office Wi-Fis, in cars and trains and charging stations in Finland. And the system is doing the exact same thing no matter where it is, but it can go from very, very small to very, very big. Decentralized. This one is again, it's a psychology that I've kind of noticed over last 20 or so years. I think decentralized is a good word anyway. We might overuse it a little bit. But what I mean by decentralized is that if there is a technology that's going to have a massive impact, and I believe connectivity could be one of the biggest ones, driving, AI driving, whatever metaverse is going to be or not be, but I do believe it's going to be one of the biggest ones. Over the last 20 years, what I've witnessed and what I've observed is that if it's truly a global technology that has a single gatekeeper, it goes up and then it comes straight back down. In 2003, I joined a company called Google, which, everyone knows who Google is now. And I was in awe not only of the culture and the environment, but what they were trying to do. I thought it was so appealing, right, to share the world's information. And the fact that, Google now is not looked at in necessarily always a favorable light, right? In my mind and in my opinion, going forward, any type of technology that will have this much of an impact has to start by being decentralized, no single operator, federated, co-opt, whatever you want to call it. And we'll talk a little bit more about what that means, at least for us, because it moves into the third pillar, which we're about to do. When you say decentralized and you say no single operator, also means extensible. So again, to kind of give an example to make this a little bit more concrete, it's like if I could buy a cell tower just for my own use to stick in my backyard. Right? And that when I'm at home, it's using my own cell tower. No one else can use it except people in my house or my flat. But as soon as I drive down the road to go to the grocery store or whatever, it picks back up with, at least for me, AT&T, right, in the States. And so it's this notion of extensibility. And I'm going to also talk a little bit about why it not only helps drive decentralized and that no single operator, but I also think it's incredibly powerful as we look at constructs around AI and metaverse, where we realize that there's going to have to be interop between different providers. And we'll talk about that as well. Security, this feels so natural, but we as an ecosystem, we still are plagued by this, but just no keys and passwords in the system. Just don't do it. They're always going to be compromised. And remember on the last slide, if I said I don't want to treat it like a pet, I want to treat it like cattle, which we do, we're going to expect these things to be attacked and compromised. And so literally no keys, no passwords in the system. The text existed for a very long time on how to do this. It's not hard. Securely multi-tenant, at least from my days back in the 90s, we used to call it the Coke and Pepsi problem or the FedEx and UPS problem. But it does need to be securely multi-tenant. And there needs to be the notion of secure sharing between tenants, almost like Facebook friends. We both agree we should be able to share data across that secure boundary anywhere, right, in the world, so to speak. So secure in motion at rest, but also the notion of zero trust constructs, right? Even if data is being encrypted over TLS and it's being encrypted on disk, what it's moving through does have access to it, right? It's unwrapping it. In university, at least when I was going in the 80s, it was always taught that any type of crypto should be applied to the payload, not the transport. But the world we live in is always applied to the transport, TLS, OpenSSL, the red phone, right, the bat phone, so to speak. And so this notion of zero trust constructs is like, I don't have to trust anything about the system, and I feel secure. And there's a lot of nuance to that, and we'll talk a little bit about what that means. And then persistence. So when we talked about the notion of, or at least from my perspective, the notion of cloud and edge, and the fact that, in my opinion, cloud is going to quickly become the new mainframe, and that edge is going to be where all the interactions are. I believe there's a second kind of attached corollary around data, where there will be these massive data lakes and these massive databases and these massive training sets. But again, I think we're going to treat those like the cloud as well, meaning that we know they exist, but we don't necessarily have to interact with them. And so what's going to be the interaction model for ourselves is going to be smaller, more purposely built data sets that can easily flow and move at will without manual intervention. And we'll talk about that. So that was persistence. So the other things, the other things around persistence that I think are really important is this notion of materialized views, meaning I shouldn't have to totally switch my whole mental construct outside of how I want to semantically process the data, beyond what the actual implementation of storing the bits on disk files, whatever that is. Should be replicated, obviously, whether it's fountain codes or Reed Solomon or just plain old, I've got 5 copies type stuff. That's kind of table stakes in my opinion. For me, the other one, when you look kind of southbound into the system, materialized views is looking up towards the developer. Southbound is looking at kind of what the actual system is doing. The notion of being able to create digital twins, or what I call source mux and demux, which we'll explain a little bit more in a second, is incredibly important and powerful in terms of that data being able to ebb and flow. And again, we'll root this in an example here fairly shortly. So for us, what we asked ourselves was, where do we think the majority of a developer's use cases are, the 80-20 rule, for the next 2 to 5 years or so? And can we actually materialize these views inside of an application with a single open source technology, such that 80% of the use cases for persistence are handled, instantaneously? And so for us, at least, we did single message, obviously, but globally ordered set of messages. So think like stream processing. But the reason there's an asterisk there is that, remember, if you can decompose any external state into a globally ordered set of messages, that means this technology can replicate that external data store as well across any cloud provider, any region, out to an edge provider. And then we did key value store and object store. And again, there might be more than this, and we didn't want to boil the ocean. You notice that there's no relational data sets, which are extremely important. But we feel like a lot of these edge things are really utilizing these types of basic constructs. And so when we're talking about the sources and mirrors, the going down below is this notion of an intelligent digital twin. So bit for bit, byte for byte, it's exactly the same. And again, these systems, based on that one fundamental, are always self-healing. Meaning if they're going across multiple cellular connections or satellite connections, it doesn't matter. And if that connectivity is lost, the system puts itself back together. There's nothing that operators and the app developers actually need to do. One of the other big patterns that we see quite a bit in Industry 4.0 and IoT and even, web and what's becoming kind of this gaming precursors to whatever metaverse is what we call source muxing and demuxing. So muxing is, let's say, every cell tower is collecting its own telemetry data. And then in certain regions in the cloud, it's actually muxing all of those streams into a bigger stream. And then demux is just the reverse. I want to go in and demux out from a massive, massive stream, let's say is terabytes or maybe petabytes big, just the cell towers that are in the southeast region of the United States, so to speak. And so this mux and demux and the digital twins are incredibly powerful. And again, we're going to try to ground it a little bit in an example. So why do these things even matter? And again, there are people that will still debate with me. And again, the whole point of this talk is to spur a debate and a discussion about where we are, how things are moving, and where we need to go. But they'll say, it's fine. We don't need any of this. We got HTTP, DNS, and CDNs and edge providers and things like that. But for me, I think each pillar not only builds on the previous one, so that intelligent persistence layer, for us, people kept asking us, Derek, you did one of these in the 90s. Why didn't you just do it when you first started this thing, getting close to almost a decade ago? And I said, the fundamental layers underneath of it weren't ready for us to be able to think differently about what persistence looks like once they're there. And so for me, it's not only that they build on them, they actually require it. So they require this location independence, nomadic, applications, end-to-end communications, self-healing, any arbitrary topology, extensible, no single operator, security. All of these things keep building on one another. And I call these massive S-curves, and there's two more S-curves in my head that I've been working on that I think will complete kind of this picture. So I kept alluding to the fact that I'm going to try to ground a little bit of this in an example. And of course, we won't go super, super deep, but hopefully this kind of resonates with the folks here about, oh, okay, I'm kind of seeing how we can compare and contrast how this might be done today with tooling that a lot of us are familiar with and understand, versus if something like this world existed, how might that look and how might it be different? And so drop dead simple account details microservice. This is not anything that would blow anyone's mind, right? You can do this with HTTP and REST and a SQLite or a Postgres database, depending on how big you were. You can get it working in 5 minutes on your laptop and be like, okay. But again, that's the what. I'm asking a question, I'm getting an answer back. But when we start to throw in this notion of business requirements, it has to be horizontally scalable. And that, by the way, has to be fluid, meaning eventually it has to not be manual. It has to be automated. It has to be multi-geo, multi-cloud, and edge-aware. Edge would, in this example, be partner sites, right? A bank might have partners that they want to interact with, and they don't necessarily trust them, but they definitely want them to be able to access this data locally without having to go back what we call origin servers or so. This is one where you're starting to see a lot of interesting experiences around edge functions and things like that, where they're like, I can get the workload to run on the edge, but to do anything meaningful, it needs the data, and the data's still way over there. And I'm struggling to figure out how to get the workload and the data to kind of understand each other and move around. And then the last one, which again kind of ties this all together, and it's a very real requirement that we're actually faced with, is globally it has to be less than 20 milliseconds. Because again, it's not people, it's not that 160 to 200 milliseconds or so, it's programmatic systems, other microservices, things like that. And so this is, actually it's good because it's on the big screen. The how of today, and all of these might not be exact, but hopefully it resonates with folks. It's like, okay, yep, we're going to have to kind of figure out these types of problems. So non-trivial DNS, right? Pinning, NS1, Anycast, maybe BGP type updates. Again, it's multi-cloud and it's edge aware, meaning it has to go into partner sites in small closets, let's say in bank partner sites or whatever that is. Load balancers, and now you need lots of load balancers, and of course they intertwine with the DNS, right? DNS is fairly slow on the uptake, right? So a lot of times load balancers are a little bit faster, but the interest graph change rate still, even on load balancers, is pretty small. Most people would say we need firewalls, lots of them, API gateways, traffic shapers, cross-cloud SecOps, right? Even if you're using something like Kubernetes, you're still going to have SecOps going, okay, how do we do this in Azure versus Google versus Amazon versus, Equinix Metal, DigitalOcean, things like that. Federated deployment, right? So K3S, K8S, service meshes, how do you kind of glue all of these things together? If anyone's actually ever done one of those, they start to have a lot of moving pieces, and they start feeling very brittle, at least in my opinion. And of course, you're going to need a replicated key value store, but remember, most of the replications that kind of come for free are scoped and pinned to a cloud provider. So then you have to figure out how to do cross-cloud provider. Then you have to do, replication into, a partner site, so to speak. And so if we rethink kind of the how, based on some of those pillars, those fundamentals, what if there's an extensible global federated utility, meaning cloud providers are running their own servers, and edge providers are running their own servers, but us as consumers can literally just connect to anything. Any node that we can find, we can connect to. And it doesn't necessarily need DNS, but it could use DNS. Think of it more like how your cell phone finds the cell tower. You're not aware of it. You usually probably don't look it up. You care about the signal strength, but you're not worried about how this thing is actually figuring that out. You're just worried semantically, oh, I'm trying to get on a Zoom call or read my email or watch TikTok, something like that. And again, because it's not only cloud and edge providers, but also extensible, that means it can go into stores and factories and homes and offices and cars like we talked about. And then this notion of declaring intent. And declaring intent is not something brand new by any stretch. I'm not trying to claim that whatsoever. But when we can declare intent over a truly multi-cloud geo edge-aware type of a system, it becomes a little bit different in terms of the experience. And so thresholds. I want to run 100 of these responders and 20 of the key value digital twins. And this notion of attractors, which is one of those S-curves that I've been working on. In a prior life, I designed 3 deployment systems to date. People might be familiar with one, Cloud Foundry, which was an early pass, kind of like Heroku, but for the enterprise that I did. And then I started a company trying to do the things I thought I screwed up. But you can imagine saying, oh, I want to run these thresholds. And then there's this notion of attractors. It's like, what are these things attracted to? Well, The KV, data store can be attracted to where the requests are coming from. The responders can be attracted to where the KV is, right? And you can see all of a sudden this notion of the system being able to move and respond. One of the fundamentals that I didn't talk necessarily directly about, but is important, is that the system needs to be naturally observable. It needs to be secure, but it needs to be naturally observable. You don't have to do unnatural acts to do latency tracking and thresholding and things like that. And then, of course, the trust factor, right, which is who do we actually trust? Because, again, it's not going to be a single provider that's running all of these nodes. And how do we actually figure out which nodes might I trust, or which operators might I trust? And then, of course, at least for me, it's deploy in any system. And so I get very nervous, a little bit, not skeptical, but just nervous around if connectivity and constructs around connectivity are always built into a deployment system, meaning I'm restricting my choice. And so every time you see something like Service Mesh, which has a lot of amazing ideas, a lot of the things that they're doing, these types of systems can do as well. But I think the nuance is it's so important of where it's being implemented. And inside of K8s, it's like, well, if you pull that simple, 200-line function out, that's your microservice that depended on sidecars and proxies and service meshes and load balancers, VPCs and XYZ, right? You start to realize that the ecosystem is building these kind of concrete boots where you're kind of stuck. And so for me, when I say deploy, I want to be able to deploy on Metal, on a Raspberry Pi, on a VM, a container, WASM, Kubernetes, whatever is going to kind of come after Kubernetes. And I've been around long enough that I know something will come behind Kubernetes. It always does. What does that actually look like, and how do these things actually intermix and go and essentially build a system like this? And so this is what we're loosely terming, and again, this is also up for discussion and debate, but these connectivity 3.0 pillars. And again, repeating this, but it's this notion of location-independent addressing is really, really important. You can't skip step one, in my opinion. The end-to-end communications, again, can't skip step two. Services and streaming, right? A single federated technology that can do both, not, I'm using HTTP, and then I'm using gRPC, and then I'm using Kafka, and then I'm using, XYZ. And there's been users and customers, at least in the ecosystems that I participate in, that some of these companies that are very well known have every single technology known to mankind. And to me, I like to make things very simple. It allows me to understand things. But even this person who was incredibly intelligent, I said, does anyone really know how the system actually works? Do you know how the security, moves across all of these different systems? And they said, no, no, we absolutely have no idea. Push and pull, secure by default, multi-tenancy, decentralized. You can read the list, but these are all kind of these basic tenets of where I think the how can transform to meet the demands of the what. Asking questions and making statements, answering questions, processing statements. And so in our world, I've been working on a technology. It started almost 10 years ago, but we really started cranking in earnest probably about 5 years ago or so. NATS is a messaging system. It's an open source Apache 2 licensed system. It still drives most of Cloud Foundry. It's probably, I think we just crossed 300 and some million downloads. So a lot of people quip that it's one of the more downloaded and potentially successful technologies that no one's really ever heard of in a global space. And then NGS is our global network. It's like our version of what this open, connective mesh and data platform might look like. And so it's open source, as we mentioned. It's our take on a modern connective and data mesh. And the only reason I'm mentioning this is that I think that it's more real than people think. This might not actually be what we end up with. And I'd be okay with that. I just don't want us to end up, 5 years from now still dealing with HTTP and DNS and that kind of stuff. It is extensible. What I mean by that is that you literally can go look at the source code for the server, build your own server, and extend our global network, which sits in all major cloud providers and all major geos. And so we're seeing a lot of users in the ecosystem and customers saying, no, I don't want to do that. And it feels like the early cloud days. What's cloud? No, I would never use cloud type stuff. So it's more of a psychological thing. But over the last 12 months, we've seen people quickly accelerate, oh, we'll just use this thing as the backbone, and then we'll extend it where we actually need and care about it. Whether that's in a cloud, mostly not, but some edge. But mostly it's what we consider the far edge or near edge to the consumer. So stores, factories, distribution centers, cars, trains, that kind of stuff. It has scalable microservices and streaming. And what I mean by that is, remember on the previous slide I said just run it anywhere? We literally can show a global microservice in every cloud provider and every edge provider, and we can scale these up to thousands of these things running, and every request will be answered by the optimal responder. And we can spin all of those things up without any infrastructure starting out with in like a minute, 2 minutes. We don't need Kubernetes. We can use it, don't get me wrong, and K3S is one that we like because we actually partnered with SUSE, and now we're actually embedding inside of K3S and replacing etcd in a lot of Industry 4.0 and IoT stuff. So when I say scalable microservice streaming, what I'm trying to impress is that very simple, very straightforward, secure by default, and very quick to scale up and scale down. Our interest graph propagation is, for most part, speed of light. And then, of course, the persistence layer, right? This notion of I can have a stream or a key value or an object store, and I can create digital twins of these things, and the system will automatically understand the ability to actually access something from a KV that's a read request from the closest digital twin without ever restarting the application. Don't have to reconfigure it, don't even have to bring it down. And so we do demos a lot of times where we're trying to show the power of what this looks like, where a microservice interaction, which could be to a KV, because it's just asking a question and getting the answer back. Let's say it's taking 180 milliseconds or whatever, and it's inherently observable. You can see this, right? You can see that, wow, that person on the West Coast of the United States is getting a bad experience. And through either manual operation or autonomy or whatever, you can say to the system, hey, create a KV on the West Coast. And in our world, that usually takes, again, speed of light. If it's lots and lots of data, it takes a while for that, depending on if it's going over big eye internet or not, which is a little sketchy these days. How fast that comes up to speed. But as soon as it's up to speed and it wants to participate, it literally says, I'm interested in the same thing everybody's interested in, request to ask for a key. And so the next request from that application all of a sudden takes 2 milliseconds versus 180. And so what we've described, at least in our world, is very real. It's already running. It's open source ecosystem that I think is again, not as globally known as a lot of other ones, but it's starting to pick up at a breakneck pace. But what I want to talk about in the last minute or so is what do I think is coming next? I really think that deployment is going to start to be driven by connectivity, not the other way around. The shiny things that we still think about are deployment. Ooh, I can run Kubernetes there and I can deploy something. I can deploy my container over there. I can deploy this WASM module in fly.io in any cloud provider. And then you kind of go, ooh, how do we wire all this stuff together? And then you're back to that DNS and load balancers and traffic shapers and API gateways and XYZ. I actually think we're about to turn. And what's going to happen is that deployment is going to move towards where the connectivity is not only the best from a physical substrate perspective, we have a lot of that already, but from the intelligence factor. I believe that dealing with transports and encodings, which I've dealt with all of my professional career, they should just disappear. I don't care if it's over TCP or Quick3 or if it's over a low-level cell or satellite protocol per se. And I don't care if it's encoded in JSON or message pack or Captain Proto or whatever the heck those things are, protobuf, right, which is very popular. So I think those become boilerplate and just go away. I think zero trust is going to become incredibly important. And the reason that I think it's important is I believe that this massive wave of machine learning and AI, even for some of the best providers, the Googles of the world, the Meta and Apple, so to speak. Yes, we're going to see pretty massive improvements in algorithms and multimodal algorithms for sure. But I think the notion of tapping data, these companies are running out of their own data. they're going to have to start democratizing and asking for other people's data, right? And Google already does this a little bit with maps if you watch what it's doing underneath the covers. But I think this is going to become pervasive. And what you're going to see, in my opinion, is very quick regulatory changes that say your data or this system's data is its own data, and that you have to give permission for other people to use it. For example, like Netflix, right? Netflix probably knows more about my sleep schedule than anybody. That's eventually going to change, and they're going to have to incentivize me for that. And so this notion of multi-party exchanges, right, is going to require this notion of zero trust. And whether that's ZK proofs or whatever that stuff is, I have my own opinions on what that may or may not look like, but I do believe it's going to become pretty dominant pretty quick. And again, I think AI is driving a demand for not just connectivity, but intelligent connectivity. And again, you can see the proliferation and very nuanced changes of AI moving from a single system to, hey, we train one way and we do inference the other way. Training is going to the cloud, big GPUs. Inference, I think, is going to go to CPUs or very specialized hardware and very, very small devices. But again, you're going to have to start democratizing access to data. People want to start training at the edge, right? Doing federated east-west learning. They don't want to have to batch upload everything to the cloud, train it, and 3 days later you get an update. And so we're watching a lot of these demands firsthand, talking with some of the domain experts. And then again, whatever you believe metaverse is or is not, and I don't know necessarily what it is going to be, I do believe something will come of it. And so we're watching a bunch of folks who are pressing the envelope in these areas, and every time they try to press, they keep coming to the same conclusion. We need more intelligent and faster velocity connectivity. Industry 4.0, smart infrastructure, there's quite a bit of other ones. Even the notion of brick and mortar stores wanting to move at a faster velocity and become smarter and more personalized. You can't trombone all the way back to the cloud on data that's a couple hours old to kind of do those types of things. So if you want to learn more about at least how we've envisioned this world, again, this might not be where we end up in 5 years, not only us, but just the ecosystem in general. But if you do want to learn more, NATS is the project we were talking about. Again, it's an open source, part of the CNCF. I was a founding member of the board for the CNCF way back in the day. Rethink is kind of a collection of videos that kind of help you kind of cement some of these constructs that I was kind of talking about in kind of real world scenarios and examples. And that's by example is how to do lots of different things. And then the Slack channel is becoming very diverse in terms of the conversations and discussions that are going on. Thank you. Hopefully this was helpful. I'm happy to answer any questions. Again, the whole reason for my talk was to encourage people to start discussing and debating and I think challenging what we think is the status quo. Thank you.